la siguiente disertación, que está a cargo de Michel Defayette, en donde nos va a presentar métodos de evaluación del impacto cualitativos y cuantitativos de las obras y de los proyectos, obviamente, de obras subterráneas. Estos métodos se basan en la normativa que hoy en día se está desarrollando en Europa, pero fueron desarrollados dentro del CETU, del centro que preside Michel en Francia, con la colaboración de profesionales en toda Francia, y a través de ellos vamos a poder ver más prácticamente y sobre la base de ejemplos cómo podemos hacer estos estudios y los marcos que nos permiten llegar a conclusiones y a comparar los beneficios y los pros y contras en este área de distintos proyectos. Los dejo con Michel.
Thank you, Martin. So this second presentation is the continuation of what I explained before, also what Robert explained before. I wanted to be more illustrated, and on one or two examples, we can have some ideas, precise ideas of evaluation and the impacts of one technique or another one. So this is more precise. Just to start, okay, I think it works. Yes, as preliminary remarks is just to do the junction with the previous one. I remind you that tunnels, of course, is a mixed picture of global impacts because, of course, many opportunities are offered by underground infrastructure. Don't we forget, when we talk about impact, we lose this aspect, and it has not be forgotten. New spaces for project, possibility to cross major obstacles and create accessibility to new places, preservation and freeing of valuable surface land. This is very important point, of course. You go down and you avoid the impact on the surface, and also reliability for vital services, water, communication, heating. But, as we said before, tunnels can also have very big impacts, both on economy and on environmental. On economy, we know that tunnels cost a lot, heavy costs. So heavy cost at the construction and also heavy costs during operation. Also very strict safety requirements. After a few very important accidents, fires, I'm coming from France, and we had the Mont Blanc tunnel with very big fire in 1999, and after that, after a trial, the safety requirements changed, and they ask social needs for very, very high safety level in tunnels. So this is very costly also. Tunnels, it is a large-scale work. The duration of the work, the worksite impacts, spoil disposal, all the process. Robert talked about that. So it means that very heavy impacts and consumption of energy, materials, and natural resources. So this is a mixed picture. And as I said before, we must be able to have an objective assessment with the following requirements to take into account both all these impacts, both positive and negative, to take into account construction and operation phases, and also to be able to point out the main issues in order to identify the best levels of action. When I explained all the parameters, we have to select what is important and to focus and to put the effort on certain of the parameters. It's not possible to do everything, but we can define what is the main action to do. And also to bring appropriate answers at all the stage, could be in the design phase. I am in the design phase. What do I have to do? And later on in the construction phase. So this is a continuous process. Last point to remind, is the fundamental difference between the upstream phase and the downstream, as I explained before. If you have the upstream phase, meaning at the beginning of the study, you will compare very global solutions. Not only the tunnel part, not only the tunnel stretch, but you have to compare from point A to point B, the new link. There is a tunnel, but also there is an open air road. So you have to compare completely global solution, taking into account not only environment, but social, economic, environment. And to take into account these three components, usually we can do mostly by qualitative approach. Most of the criteria cannot be evaluated completely. So in this phase, the qualitative approach takes a major place. If you go, we'll see later on for the downstream phase. And you have at this phase also to deal with very imprecise elements. The project has not been studied completely. So we have general view of what it could be. So it means we have to work only with these imprecise elements. The downstream stage, detailed design, it's not global solution you compare. It's construction method. And so you can select one way to excavate, another way. You have choose one solution to other, but you can use quantitative methods because you can get all the environmental impacts of all small elements. And there are databases, a lot of databases, that can give you the fundamental elements to go to a global evaluation. The upstream phase, I will go through an example. This is the scheme I showed you before. I will not go ahead in this scheme another time. This scheme has these several criteria in different colors that have to be taken into account. I can explain on an example. This is an example of a small road tunnels, 600 meters. It's not very long, on a new road. But the new road is 6.5 kilometers. So if you want to compare solutions, of course there is a tunnel, but this is globally a new road. The social, the economic evaluation is to be made for the global project. And as a tunnel specialist, we will provide the elements about the tunnels to the global evaluation. What is important for us is to be able to bring or to provide elements about the tunnels. In this case, 29 criteria were defined. So for the 7 different categories I showed you before, the 7 groups of elements corresponding to 29 criteria. 29 means 4 to 5 criteria for each component. So I will explain. So there is in 29 criteria for a qualitative approach. Some are related to social aspect, some to economic aspect, some to environment, and then we can rank the solution according to their impact, which is important or not. So it's a way to take account of the whole panel of the sustainable approach. In this case, I make a zoom because you couldn't read the document before. If I go through what we call environmental dimension, in environmental dimension, there are some sub-items, impact of the environment, which is the local impact, economic management of natural resources, another one, which is all kinds is detailed. And so we can proceed with the people involved in the project to a global evaluation, a global ranking of all these aspects. So it's only qualitative because there is no way to give an evaluation at this time. We are very early in the study, and so elements are too imprecise to give figures, to give precise figures. And so we go through the 29 parameters, and you can show the result below. We have a scheme with all the dimensions: social, environment, variable, meaning the interface between social and environment, economic and environment with an interface called viable, and economic and social, an interface called equitable. And you can see, for example, the profile of the impact in blue for one solution, mainly with big impacts according to the seven group of parameters, and the other one, the red, another evaluation profile. So it gives a global view considering all the dimensions of sustainability, a global view, and mostly a comparison of the solution. Probably the evaluation itself is not so good, but what makes sense is the comparison between solutions. It's merely a tool to compare solutions. Of course, it's difficult to separate the tunnel from the new link it creates. This comparison has to be made with point A and B and a global solution including the tunnel. Making it only for the tunnels doesn't make sense. It has to be a comparison between the main options. So in this case, the advantage is to take into account all the dimensions of sustainability. When Robert presented a slide a few minutes ago, you see all the criteria for environmental impacts. There was a nice picture, and we saw all the things to consider. But it was environment. If we talk about sustainability, we have also the social and economic. And as he said, some project can be socially necessary, even if its environmental impact is important, is high, because it's a social necessity. So in this upstream approach, all these dimensions are taken into account. So only a qualitative approach is possible. And of course, the main problem is that it's very subjective, because it depends on the people involved in the evaluation. And sometimes other people will evaluate it in a different way. The method, the criteria are defined, but it's the load that people give to all these parameters. So this is of course, a problem. What I showed you also of the research from Netherlands is exactly the same. We have a lot of parameters, and they defined priorities. So they give priorities to different criteria compared to other ones. It was not done in this case. All the parameters were considered the same load, the same weight in the balance, in the evaluation. But you can also give different weight to different criteria according to what is your priority. So this is the case. Difficulty to identify the single tunnel inside the overall infrastructure project. Of course, if a tunnel is only a part, you have to consider the whole. this approach has to be also, when you consider the tunnel, has to be pertinent for the tunnel, meaning that it has to be adapted to what is done for open air. So there is specific works to do to, for example, economic, social, to take into account the tunnel specificities. And if you want to go to quantitative, in this upstream stage, you need a ratio. If you have global ratio of the impact for carbon dioxide, for example, as Robert showed, you have to have ratio. You say 1 kilometer means 40,000 tons of carbon dioxide. So in the balance, you can do some calculation, but it's only a ratio at this stage. Downstream stage. The downstream stage, you can now optimize the technical choice. Tunnel has been decided, we know. We know exactly where are the portals, we know what we have to do, that's okay. We know the transverse profile, that's okay. It is a 2-lane road, it is a train. We know exactly what we want to do. So now, how do we construct the tunnels? Could it be mechanized, conventional? How to organize it? What to do with the spoil? What are the support method? Do we not pre-support, umbrella support, steel arch, shotcrete? All these aspects have to be defined, and there are a lot of solutions according to contractors, practices, and that's so on. But in this stage, when we have a detailed design for each solution, we have a lot of information of the methods and the means. A contractor will define exactly how he will do and what he needs, material, support, all the quantities. And so you can calculate the effect of one method or another one. All the construction steps can be described, and we can identify each elementary task and the corresponding action and supply requirement, what I explained. And so we can say, we can do an evaluation. It's very, very close to what we do for cost. If you have a detailed breakdown of the process, the quantities, and you can make a cost evaluation. You can make, according to the appropriate database, an environmental comparison at the same time. So the method commonly used is life cycle assessment method. This method is standardized. It is interesting because it considers all the tunnel, I say, as a product system, and all the tasks are examined in the incoming and the outgoing elementary flows. What is needed for the tunnel construction, what I use, and what is going out, emission to water, air. So all the steps, all the elements are decomposed to identify all the flows. And we have very interesting and complete databases. If they are not complete on every point, every day there are new elements in these databases. This is very active. This is a very active activity to produce new database, and there are worldwide elements, worldwide accepted elements now. And so we can calculate the global environment. I will show you an example because it will be very useful to explain. So the method to evaluate the impact is defined now by standards. This is a life cycle assessment method. It was firstly developed for buildings, and I explained that buildings are more advanced than we are in civil works, but so we can get elements and experience from them, and then it's applied to bridges, tunnels, and public works. These methods consist in 3 main steps. First, to identify the problem, exactly what we want to evaluate, to quantify the inputs and the outputs, to make an inventory of all the inputs and outputs, to calculate then the impact indicators from the database. And so then there is a global interpretation. Okay, we consider the whole life cycle of a tunnel, of the phases. In the case I will show you, I will not consider all of them. I will just to illustrate, I take 1 or 2 items, and it's more easy. It's easier to explain. In this case, for example, there is a breakdown for all the different elements you have to consider according to conventional tunneling or mechanized tunneling. It means for the machines to be able to work, for the staff to be able to come and to work, to implement the logistic base, to the excavation of material, all we need for concrete for support, concrete for linings, all kind of material we need for support. So you have the inflows, the outflows, and all the means required for both conventional and mechanized. And in my example, I will consider among all the indicators, they are the same that Robert showed you a few minutes ago, the 3 main ones: consumption of energy resources, depletion of resources, and climate change. So we can make an evaluation for these 3 indicators, the same methodology for the other one. And I will consider, in the following example, a conventional drill and blast tunnel. I will consider the material we need for support, for lining, for drainage, for watertightness, donc the material we need. And I will consider the operation phase, so the energy supply for ventilation and lighting. So this example will be done for a life cycle of 100 years. So this is the example. Let's consider conventional tunneling. This is the shape of the cross section, and according to the ground, 3 different support profiles were defined: a light one with only shotcrete and bolt, a medium one with ribs, with steel ribs added and for support, and an heavy one which is inverted with inverted arch with strong steel arches and also thickness of shotcrete. So this is classical profiles for conventional tunneling. So we consider that. We consider also the types of concrete we use. There are different types for the lining, shotcrete. So there are the cement content, the type of the aggregates, and so on. Also, they are different. So we try to be precise on this question. For the operation phases, we needed to have an idea of the consumption for lighting and ventilation. And we had a review of a large number of tunnels. And so we estimated that the range, there is a lower limit and an upper limit of consumption according to the length. This is the, for example, the lower limit is the green one, and the higher limit, the highest limit is the red one. So we have an ID between two limits of the consumption. Of course, they are different between an urban tunnel and a countryside tunnel. So there are many factors to explain and to adjust according to the context. So this, for example, consider the different, you see the different indicators. So consumption of energy resources, depletion of resources, climate changes, the first three, surrounded by a blue line, and other parameters. If we try to estimate the relative parts of impact of the materials for the light profile, it's what we get in this case. This is the light support profile, bolts and shotcrete. And so we can see in green, in the upper part, in green, this is the part of the lining. So we can say that the lining is something like 40% of the global impact for consumption of energy resources for the light profile. So the support, for example, is the blue one. So the impact of the support is very small, but at the same time, it is the light support profile. So what we can see also is there is no big difference according to the indicators. You can say the first one, we can say all the indicators, the columns, they are not so different. So contribution are roughly the same, whatever the indicator is. So for the light profile. If we go now to compare the support types, this is the light support profile on the left, the EV1 on the right, and we see for consumption energy resource indicator a very important increase of the impact for the EV profile. And if we go to examine this figure, the blue part is the support itself. Of course, when we go from the light one to the EV one, we add steel arches, thickness of shotcrete, we add a lot of elements, and the part of the support increases a lot. And so you can see, for example, if you choose to have, let's say, half of a tunnel with a very heavy support, which is not necessary, probably you will have a big impact, because there is between the small one and the big one, the ratio is 3 times more impact according to the profile you choose. This is just a rapid exam. If in this case, I have also the 3 profiles, but for consumption of energy resources, but it is drawn in percentage, meaning the percentage of each element of the tunnel for the light profile and the heavy one, for example. The light profile, the major part is the green one, which is the lining. But for the EV profile, the lining is only 20% of the impact, and the support is something like 60%. So we have, as we increase the strength of the profile, we have a significant, the support becomes, of course, the main impact. But also we have significant contribution of lining and road beds. If we go in the support part, we see, for example, in this case, comparison between the light profile and the heavy one. In the light profile, the part of the steel in orange is far small compared with the concrete one. If we go to the heavy profile, of course, the part grows and becomes more important. What is important? So there is no surprise about that. But what is surprising is that a steel has a very significant impact related to its mass proportion. Even it's only a small part of the support, in the impact it is a very strong part of the global impact. Steel, of course, is very impactful in the approach. Another example in this case, I remind you that we consider the operation phase and the energy supply during operation. If we can see in this example the impact of operation compared to the impact of construction. And so, for climate change indicator and consumption of resources. And we see that for climate change, the part is relatively small of operation compared with construction, but for consumption of resources, operation has a greater impact in the global approach. So the construction contribution is important, 10 to 60% for consumption of resources, 40 to 90% for climate change indicator. This is just an example with only a few elements that have been considered. Of course, if we add all the elements in the evaluation, could be some difference. But the main conclusion at this point is that there is not one phase which is far more important than the other one, and would say one is to be considered and the other one can be forgotten. No, both construction and operation are important, whatever the indicator you take into account. This is just another illustration in this case. When we enlarge the tunnel section from 2 or 3 lanes for traffic, we try to see what is the difference. Of course, the impact is a little bit more important when we have 3 lanes instead of 2, but the global proportions remains. Moderate impact of supplementary lane at the tunnel design. So we can do a lot of interpretation analysis from the data we get. The example I've shown you in the construction phase, we focused on material quantities. The material quantities, the steel we need, the concrete we need for support, for lining, etc., etc. If we want to go to a global evaluation, we have to consider all other elements. You see, material quantities is what I consider in my example. It explains what I care when I conclude, because it's only a small part of the analysis. But if you want to global analysis, you have to consider the working machines, energy consumption, maintenance, amortization, transport, the material, of course, the quantity, transport, the staff, the travel of the staff, impact base camp, waste, handling of the waste. So there are different items to be considered in a global evaluation. But the methodology to do that, inflow, outflow, database, and then with an inventory is the same. In this case, for example, we try to evaluate the working machine energy consumption. Always, I'm not talking about TBM, working machine for the conventional case before. So we have to break down all the tasks. So this is the duration of the daily task in minutes. So all the daily tasks. Of course, we have for example, drilling and blasting, ventilation after blasting, mucking, support installation, geological survey, dead time to repair, and then cycle again and then again. So from a light profile to everyone, we have an idea of the time we need for each phase, and of course, the time the machines will work to do the job. We need that. Once we need that, we can calculate the energy consumption for all these tasks. And in this case, for example, we see which is the energy consumption for each of these tasks. And of what appears is the mucking phase. The machine for mucking phase is the most important. It was in this case. The drilling first before blasting is also important one. Bolting, ventilation also, ventilation for the work site. So we can calculate precisely the energy consumption for each task. As the methodology, we know exactly what we are going to do. We know how it will be organized, the time it will need, and so calculation can be made. To conclude on my example on conventional tunneling, in this case, we can see on the bottom, these are the impact indicators. EP, first one, for example, consumption of energy resources. CC, climate change. So we have 7 indicators. And then the impact, the comparison of the different, the machines, the materials and transport. For example, the first column, which is consumption of energy resources. The material we need to do the tunnel, 65% of the total amount of consumption of energy resources. The work for the machine energy is about 30%. And 5% is the transport of machine, of material, or kind of transport. And so we can do that for all of the indicators. The meaning of this is when the methodology has been defined, we can do such an evaluation. And it allows us to do some improvement in the way we support, in the way we organize all the work. We know how to do that for cost saving. We know that if we choose one solution to reduce the cost, we can make some improvement in the proposal. We can make some improvement of what the contractor is giving. But this is the same. We can do some improvement according to the climate, the global indicators. In the case I show you now is something a little bit different because it's a comparison between the material we use in conventional or mechanized tunneling. This is of course, the requirement for support, the requirement for lining is a little bit different. I don't speak about the machine construction or T-bend construction. This is something different. I speak about the material we need to put in the tunnel, compare with two. And so, if we look at the indicator on the right, we see that the main impact, according to all indicators, is a conventional tunnel with an invert. Of course, there is the steel, the concrete we need for the invert arch. And without invert, if there is a good rock, the impact remains important according to all indicators. And it's less important in the case of a circular mechanized tunnels. So it's because the quantity of material, the quantity of steel, quantity of concrete, etc., on this material impact, the discrepancy between conventional and mechanized is about 20% in this case. I give you some ratios. This is what is deduced, is calculated from detailed analysis and can be used for the upstream stage. And you can go through the literature. There are different documents, and the results are quite the same. What is important is construction of a tunnel, could be a two-lane road tunnel, a three-road lane tunnel, or a railway tunnel at the same size. The climate change indicator, it's, let's say, about 7,000 to 20,000 kilogram equivalent carbon dioxide per meter. So if we say that for the construction of 1 kilometer of tunnel of the size of a two-road tunnel, it's something like 20,000 tons equivalent dioxide carbon can be good indicator to make calculation. And so these are the comparison between electric consumption 100 years is 2,300, so it can be compared with the other one. So there are many indicators we can calculate and use for an upstream comparison. I'm close to the conclusion. Conclusion for the downstream stage. So we have a significant influence of the construction materials in comparison to operation. So what I said, both phases are important. We have to make an effort on both aspects, construction and operation. The methods give ratios and orders of magnitude, and we can use them for the rough comparison and the upstream stage. It also helps us to point out the main issues where to concentrate our effort, because it's not only an exercise, global exercise, it has to help people to see where to put the efforts. And the database we use are nearly completed now. There are a lot of elements, and so this kind of comparison can be done in a proper way now. And what I say, it's not so different from a cost estimation. When the breakdown is made to be able to calculate the cost, we can also get a lot of information about the environmental impact. My proposition, and we used it already, is to ask to the contractor, when in the tender phase, to give the description of the solution, the cost, the detailed cost of the solution, and also the detailed evaluation of the environmental impact. So we get directly an idea of the quality of what is proposed. Conclusion. So qualitative and quantitative are complementary, because when I saw in the design phase, it's very difficult to take into account social and economic aspect. It's more in upstream phases. Research is still working to complete the databases, but I think significant progress is done, and so it's important. International guidelines are published, and a lot of people are working on this topic just to precise the methodology and get a standard about this. And so probably what I conclude is certainly a good way to promote and demonstrate the need of the underground for a sustainable development of city, because we know that underground solutions are very useful in very big cities, because there is all this space, underground space, can be a place for very interesting project, very helpful project. But if we say this is good for sustainability, sustainable cities, okay, but it's not enough. We have to demonstrate, we have to calculate, we have to prove with elements that it is a reality. And so this can be very helpful. Thank you very much.